So this is a pretty good one. What happens if we take x to infinity here? We get 1 plus 0 to the negative infinity power. Well, in the first video of this series, you'll see that this is one of our indeterminate forms. It is not a form that L'Hopital's rule can deal with directly, though, so we need to do our trick again. We are simply going to rewrite this limit. And the reason that we do this is to take advantage of the property of logarithms that says we can take this power on this argument of the logarithm and bring it out in front of the logarithm. Okay, now if we ask what happens as x goes to infinity, this piece right here goes to infinity, while this piece here goes to the natural log of 1, which equals 0. We have infinity times 0. That's an indeterminate form that we can more easily write as a form that L'Hopital's rule can deal with. I'm going to copy everything down, except I'm going to take this x here and I'm going to move it to the denominator and call it 1 over x. Now, if we take x to infinity, up here in the power of e, we get a 0 over a 0. And that is something that we can use L'Hopital's rule on. Taking the derivative of the numerator is not a small task. We can copy the constant down in front. The derivative of a natural log is 1 over the argument, but then the chain rule says we have to multiply by the derivative of what was inside this natural log, which is going to be negative 1.5 x to the negative 2. Okay, a little bit messy here, but let's take the derivative of the denominator. That's going to be a little bit better. That's just negative x to the negative 2. Now notice some things cancel. The x to the negative 2's cancel, the negatives cancel. Let's see what we're left with. We're left with a negative 5.5 times a 1.5 over a 1 plus 1.5 over x. Now if we take x to infinity here, this term goes to 0, and that's all that happens. We're just left with e to the negative 5.5 times 1.5 over 1. That is just e to the negative 8.25 power, which is a perfectly fine answer. But if we want a decimal approximation to this, it's going to be 0.00026126126, we'll say. I kind of like this answer because it's nice and clean. Now, I'm not going to do a full bonus problem here, but you might ask yourself, what is this limit? Get rid of the 1.5, get rid of the negative 5.5, kind of walk yourself through this process, and you'll see that you'll get that this limit is just e. And that's a limit that turns out to be at least somewhat useful in your future, so that's a good thing to hold on to. Okay, I think that does it for this one.